How much sweat does the average adult produce in a year? Is it A, enough to fill a large water pistol, B, enough to fill a bucket, or C, enough to fill a family car?
In fact, the answer is C, enough to fill a family car. 1,264 litres to be precise.
Ugh. This is a case for investigation, ouch. Ugh. Your feet have over 250,000 sweat glands. Sweat is mainly salt and water, but when you mix it with the otherwise harmless bacteria that live on my feet and the warm, moist socks that they live in, it's a real feast. And what you're smelling is the waste products from the bacteria. Ugh.
This is Loughborough University, the place to come to study all things sweaty. We're going to find out why we sweat and find out where we sweat the most. Using some high-tech equipment and this sweat collection vest, we're going to collect Chris's sweat.
Now I've got to run on this treadmill in this room, which is kept at 50 degrees Celsius, and I promise you that is really hot. If your bath was this hot, you'd burn yourself.
Off you go then.
I'm just jogging, you know, if I was doing this outside, this would be relatively easy. And I've just got these fans in front of me, blowing hot air at me.
Running in a room which is 50 degrees is causing Chris's body temperature to rise dramatically. If it rose to the same temperature as the room, he'd definitely be dead.
So I need to lose heat, and it's very hard to lose heat when the air around you is hotter than you need to be. And the only way you can do it is by sweating.
So the reason we sweat is to take the heat energy away from our bodies to allow us to cool down when we get hot.
But it doesn't work very well when you put on a bin bag that stops you evaporating the sweat.
True, but you can't stop running yet. The sweat Chris is producing is not only full of salt, there are other things lurking in there too.
And in fact, sweat is a lot like your pee. It's a lot like urine. So you can think about that next time you're licking it off your upper lip.
Gross. I think we've got enough sweat though.
Okay, let's stop, Chris.
This is Professor George Havenith, an expert in sweat. Well, it's a smelly job, but somebody's got to do it. He's weighing all the pads from Chris's vest and shoes to find out how much sweat he's made and where the most sweat has come from.
So he just measured me, and I'm a kilo lighter now than I was at the beginning of my run. And that is that much sweat that I've made, which is quite a lot in half an hour, isn't it?
It is a lot, yes. Typically, top athletes would go up to 3 to 4 litres. I think you, with just over a litre in half an hour, 40 minutes, that's a great performance, I would say.
I'm slightly offended. Slightly offended. I thought I was a top athlete.
Dream on, Chris. Anyway, let's find out where you are the sweatiest.
We compare the different values for the pads. What we see is that you sweat a lot more on your back, on your spine, rather than on the front.
Really? Okay.
And that's typically what we find in general when we measure people. The sweatiest part of your body is your forehead, with almost everybody. Usually about double the amount of the rest of the body. And then the back is the second part.
What about my feet?
Yeah, surprisingly enough, feet sweat a lot less than we think. Usually we have feet in shoes, and that, of course, encapsulates the sweat, and that's why we think they're very sweaty. But when we exercise, feet sweat only about a fifth of the rest of your body.
So, we now know that Chris's feet are not the sweatiest part of his body, but are they the smelliest? Let's find out.
So I've been running in the heat room, I've sweated masses, but which smells worse? The pads from my body or my feet?
You've got to find someone willing to have a whiff first, though.
No thanks. No thanks, you sure? Yeah. Just smell my trainers? No?
First, sweat from his body.
What do you think?
Not very nice.
It's not a great smell, to be honest.
OK, try a trainer.
Oh, that's awful. That's disgusting.
Oh, yeah, they're bad.
Oh, grim.
Anyway, I think we've got a whiffy winner.
My feet were by a long way the smelliest, and I don't find that surprising. These are Zahn's trainers.
Oh, that's where they went. But it's clear that despite our feet being less sweaty than other parts of our bodies, they are indeed smellier. And that's because they're wrapped up in shoes every day. But without sweat, your body wouldn't be able to regulate its temperature, and you simply wouldn't survive. Chris, you haven't seen my diarrhea sample anywhere, have you? I can't find it anywhere. Oh, here it is. Now, let's get on with today's experiment, shall we? Have you got your sample? Well, that isn't very runny. I thought we agreed on diarrhea.
Look, I just thought it might be better to compare a normal solid poo with a runny one. Now, everyone gets diarrhea from time to time, and one of the most common reasons is if you get a tummy bug, and the result is that your body ejects the contents of your digestive system as quickly as possible.
Now, as you can see, Chris's plain solid poo looks completely different to mine.
But that isn't the only difference. One of these poos weighs more. So which of them do you think weighs more? Chris's solid poo or Zahn's runny poo?
As you can see, my diarrhea poo is a lot heavier than Chris's normal poo. But why? Why is diarrhea heavier and runnier than normal poo?
Well, we're going to show you. Ah, Zahn, welcome to my poo factory.
Wow! Wait a minute! Are these my ballet tights?
Yes, I'm just using them as part of the poo factory, and they are proving to be very, very effective fake intestines. But don't worry, you can have them back later.
First up, let's make a solid poo.
Get the masher and mash.
This bowl is like the inside of your mouth, chewing up the food.
To help mash it up, your body adds saliva, enzymes, and it's all washed down with a drink. OK, Zahn, I think that's enough. It's time to move it from the mouth to the intestines.
This is like you swallowing.
Nice work. Once the mashed up food hits your intestines, the muscular walls of your gut push the food along and squeeze out all the goodness. So you can see this rich liquid full of all the nutrients and the water is coming out of the guts and going into the body, which is these metal trays. And what's left is the indigestible stuff that's going to become your poo. Well, Zahn, I think it's time to poo. There you go. Much more solid than it was at the beginning. Nice, dry, well-formed poo. We have made the perfect poo. And look how much water is in the tray. Our fake intestines managed to get almost all the water out of our poo.
This water, full of nutrients, gets reabsorbed back into the body and delivered to where it's needed. So, if that's what happens to make a normal poo, what happens when you make diarrhea? Well, it all starts in the same way.
Right, Zahn, put the food in the mouth and start chewing. Just as before, we have the same food and mixture.
But this time, our poor intestines are dealing with a tummy bug.
Time to swallow. So now something different happens. The tummy bug makes your guts draw in extra water from your body, pushing everything through your system super fast.
What I've got here is a high-pressure hose, and I'm going to use this to demonstrate what happens when your guts draw in water from your body. Chris, are you ready?
I am ready.
3, 2, 1, go!
Here it comes. Oh, that's good, Zahn. That's good. Oh, look at that. That is amazing, Zahn. Oh, that's enough. Zahn has turned my perfect poo factory into the world's first diarrhea machine.
So, we've shown you that diarrhea is heavier and runnier than normal poo, as your intestines don't get the chance to do their job.
And all the water that should have been absorbed, like the normal poo, ends up in the toilet.
And you can see that in our trays. There's almost no water in our trays at all with the diarrhea.
And that's why it's also a good idea to drink plenty of water or rehydration drinks when you have diarrhea, because they replace the nutrients and water your body has lost. Speaking of drinks, all this experimentation is making me thirsty.
Chris, I'm not sure you want to be drinking that. That's my backup diarrhea sample. Vomit. What makes our bodies do it and why? Well, we're doctors and we can tell you.
Can I get it now?
Hang on. Being sick's your body's mechanism for getting rid of stuff it doesn't want, often because there's a bad bacteria or virus in your stomach. So that's the simple answer to why we puke, although it's a bit more complicated.
Now can I get it?
Hang on. But what's vomit actually made of? And what goes on inside our bodies to prepare us for this massive event?
Now can I get it?
Oh, go on then. Let's see Chris's lunch.
This is my sick.
Oh, Chris, that's awful.
Don't worry, I'm not ill.
There is still food in there. That's because when you're sick from your stomach, it's not choosy. You bring up everything to try and get rid of that bad bacteria or virus. So what your stomach ejects is all the food and drink you've taken in one go.
But there is another ingredient in vomit. Now, Xander, I want you to close your eyes and imagine you're in a really posh Italian restaurant. Now, don't you think my vomit smells a bit like cheese? And that's because when food is broken down in your stomach, it makes butyric acid.
The acid is produced by bacteria as it eats away at your food, and the same bacterial process occurs as cheese ages. Which is why older cheeses like Parmesan smell a little bit like vomit. Just as well Chris hadn't been eating Parmesan, or his vomit would smell much worse.
Enough already. Now, I've got something even better than a tub of my own vomit. Apart from it being really unpleasant when you're sick, there are real dangers of your vomit spreading a virus. And it can lead to an epidemic, just like the winter vomiting bug, norovirus. But how can vomit spread viruses? This is Larry. He's a robot, but he's not just any old robot, he's a vomiting robot. Larry's been specially designed to show us how the virus can spread to other people when we vomit. So, I've given Larry a big drink, and he's gonna vomit into this container.
If he's ill, shouldn't he just stick to dry toast or something?
Zand. Ready to puke in 3, 2, 1. That was really powerful.
It's amazing. That might look like a much more powerful puke than a human would do, but in fact there are things like norovirus that do make you projectile vomit. It's lucky we had such a big container. I think we've caught it all.
Well, we can check that, Zan, because I put a fluorescent dye in the liquid that I made Larry drink.
Do you think that's what made him sick?
No, I think turning the knob made him sick. He's a robot, Zand. So, I'm going to go and turn on the ultraviolet lights, and we'll see if any of the splashes of vomit escaped. So there's loads in the container.
You can see it really well.
You look outside the container, see how much there is here.
Yeah, there's loads. And then over here where I am, there's even more. These are big, big drops. Some of them are more than 2 meters away from Larry.
Look, Zand, it's even on you.
Oh, yeah. It's all over me. It's just amazing how much mess he's made.
Well, this is exactly why Larry was invented, to show just how far drops of vomit can spread. And remember, each one of these splashes has enough virus in it to make you seriously ill.
So remember, if you're being sick yourself or you're looking after someone who's sick, it's really important to wash the whole area really carefully and wash your hands with soap and water to stop spreading the virus on.
But it's not all bad news. Vomiting can sometimes be your way of getting rid of things that are harmful.
This never would have happened if we'd just given him dry toast.
And now...
We're heading to the hands. Every single day, your hands come into contact with all sorts of things, picking up a lot of bacteria along the way. But just how often do we wash our hands? Well, I'm going to find out using a special scientific tool called asking people. When was the last time you washed your hands?
Just before I left the house, which was probably about 20 minutes ago, maybe.
Oh, really? Okay.
At school.
When was the last time your dad washed his hands, do you think?
I think it was never.
You think he's never washed them?
Morning.
In the morning? What time is it now?
It's about
It's late afternoon. So, maybe we don't wash our hands quite as often as we think we do. But why does it matter how clean our mitts are? Well, there are harmless bacteria on your hands, but your hands also play a crucial role in spreading illness. In fact, up to 4 out of every 5 illnesses are spread by our hands. Although you don't need to wash them all the time, washing your hands before you eat and after you go to the loo is very important, and I'm going to show you why. So, I'm gathering as many handprints as possible on a special jelly which will help to show what bacteria are on people's hands.
That's brilliant.
Next, I want to take a second handprint after their hands have been washed in water to see if there's a change in the amount of bacteria. Finally, I want to see the difference soap makes. So I'm getting my volunteers to wash their hands with soap and water.
Okay, so you do the backs of your hands. Oh, you get your in between your fingers.
This is an absolute masterclass in hand washing.
What about a nice clean high five?
Now our samples head off to the lab, where they are put in an incubator set at exactly 37 degrees, which is the same temperature as your body. They will happily grow in this perfect bacteria breeding environment for 48 hours. Keeping an eye on our batch is virologist Rhiannon Lowe.
So Rhiannon, what have we got here?
Okay, these are the plates that haven't been washed. So we've got normal skin flora that we've been growing up. So we've got lots of Staphylococcus species, we've got Streptococcus species.
And that's kind of exactly what you would expect from a regular hand.
This is normal hand flora. You can see the 4 fingers and you can see the thumb.
Check out these furry fellas.
Like to smell?
Ooh,
Yeah.
that is a strong smell.
So these are bacteria that you might find on your hands after not washing your hands after going to the toilet. So
Okay.
they will be fecal bacteria.
Yep, that means poo, and these bacteria can cause food poisoning.
So can we have a look at the next lot then?
Yeah. A lot of people don't wash their thumb very well at all, so your thumb tends to have a lot more bacteria on them.
What, people just stick their
Yeah, just wash it
fingers
like that,
under
and
the tap,
literally
but
the
their
thumbs are
are
sticking out
out
like
the way.
that.
So there's still definite handprints here. It's clear that water alone doesn't do much.
What about number 3 then?
Number 3, let's take a look.
Squeaky clean. Well, almost.
It's just a few sporadic colonies.
It just goes to show that using soap when you wash your hands is so much better.
There are bacteria on your skin that are actually doing you good.
So there's no need to keep your hands squeaky clean all the time.
But washing your hands with soap and water, especially before you eat, is a great way of protecting you from getting sick.
And remember, when you wash your hands, do it thoroughly. A good 20 seconds of washing with soap and warm water will keep your mitts clean, and don't forget your thumbs.
It's time for Investigation Ouch, and welcome to Manchester city centre. Have you ever wondered what all this activity does to the air you breathe in? Well, I'm about to find out. When you breathe in air, your lungs transfer the oxygen to your blood to keep your body going. But your lungs also have to work hard to keep pollution out. To do that, they need mucus and snot. And that's why for my investigation, I'm going to need some snot. I'll be collecting snot from the city and the seaside to see what these two different environments throw at our lungs every time we breathe in. First up, the city. We want a sample of your snot. What?
You want my boogies? That's weird!
Oh, there's a couple of nice ones on there. Well, that's the city sorted, but what about if you live by the sea? I'm now at Weston-super-Mare. Could we get a sample of your snot?
Oh, yeah!
Do we have to?
Yeah!
That's a good haul, actually. Finn, this was going to be your breakfast, wasn't it? Now we're going to take it back to the lab. So now I've got a load of snot, let's see what's in it.
There you are.
Meet Dr. Kelly Berube. She's an expert on air pollution at Cardiff University, and I've got a challenge for her. So, Kelly, I have taken nasal swabs from the city and from the seaside.
Okay.
Now I want you to tell me which is which.
It's not going to be a problem, Chris. Easy peasy.
Really?
Yeah.
Kelly's putting each sample under her microscope to see what's in it and work out where it's from.
This sample is going into seaside pile. I'm saying that that's going to be city.
Let's have a count up and see how she did. That's correct. Correct. That's correct. 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 How were you able to do that so easily?
Well, I started off with the fact that cities have more pollution. The ones that had the most soot on them, I put them in the city pile. The ones that didn't, I put them on the seaside.
You've got snot up your nose and liquidy mucus all the way down your airways into your lungs, where they trap pollution particles. And this is where mucus is brilliant. It actually helps your body get rid of those particles. But if it's bombarded with too much pollution, it can't cope, as we're going to show you. This is a scanning electron microscope. It's one of the most powerful microscopes in the world, and to replace it would cost almost £1 million. It's expensive because it can magnify up to 2 million times more than a normal microscope. Each of these metal tubes contains little samples of lung tissue, and you're about to see them close up on this awesome bit of kit. Kelly, what are we looking at here? What's this?
This is the surface of the lung, and we have these cilia. These are little hairs, and they move mucus and debris out.
So basically, all the way through the air tubes from our nose down into our lungs, we have these, what look like hairs, and they move in time and shift mucus that's trapped, stuff we don't want in our lungs, back up out so we can cough it out or spit it.
Clean our lungs so we can breathe better.
Or pick it.
Yes.
So, that was a healthy lung, but this is an extremely diseased lung. This person has been breathing in dirty industrial air 24/7 over a very long period of time. The cilia are destroyed, and that's a particle of diesel.
Remember we saw the cilia? Well, here, they've all collapsed.
So it looks like almost a field of grass where all the blades of grass have been flattened.
Oh, yeah, definitely, yes.
So if those cilia are flattened, they can no longer move the mucus back up, and you can get rid of stuff.
So now that stuff is stuck in there.
But that was a lung under extreme dirty conditions. So although the air from our cities is more polluted than the air by the seaside, you shouldn't worry too much because the mucus in your lungs traps the pollution. It then gets wafted up by the cilia in our airways, and you can cough it up or blow it out your nose. Proving your body is brilliant at cleaning its airways, and that's whether you live by the sea or in the city.
Today, we're getting to grips with your guts.
Zond, what's going on? It's snack time.
Snack time's cancelled, Chris. Because I've laid a set of pig guts end to end all over the bench.
I can see that, Zond. The smell is terrible, but it does look amazing. Why have you done it?
I just wanted to see how long it all is, really.
Your intestines are 8 to 9 meters long, but until you lay it out like this, it's hard to imagine.
It's amazing how it can all fit in your body without getting tangled. But Zond, if only we had another set of guts that you hadn't laid out, we could see that special part of your body that stops that tangling happening.
Well, it's funny you should mention that, Chris, because I've always said that there's only one thing better than a set of pig guts, and that's 2 sets of guts.
I don't think you've ever said that before in your life. But it does look like this one does seem to have the mesentery.
Yes, the mesentery, the amazing bit of your body which stops your guts getting tangled and gives them blood and nutrients. And you can see it here. This white bit is the mesentery, and there are blood vessels running through it. And you can see it holds all the guts together.
Without the mesentery, your gut would have to be in a straight line from your mouth to your bum, and you'd be as tall as 2 double-decker buses.
That would be tall.
Your guts are split into 2 sections, the large intestine and the small intestine, which isn't that small at all.
This is the small intestine, and it runs all the way from here, around here, right down to there, and this is where the action takes place. And inside, it's covered in tiny finger-like projections called villi, and you can only see them under a microscope.
Villi have an important job to do. As the food moves along and touches them, the villi absorb every tiny little bit of nutrient, including fat, sugars, and proteins, into the wall of your intestines, passing it out into your blood for your body to use.
But there's one thing about intestines we haven't discussed, Chris, and that's...
Oh, Zond, what have you been eating?
Farting is completely natural. It's just your body's way of getting rid of unwanted built-up gas. And everyone does it about 14 times a day. Doesn't matter if we're talking about your head teacher or the Queen herself. We all do it, and it's honestly not your fault.
He is actually right there. Inside your large intestines, there are millions of good bacteria that are there to help break down food.
And as they eat, they produce a mixture of gases, which is what makes you let rip.
This combination of gases is made up mainly of air, carbon dioxide, hydrogen sulfide, and methane. And the methane contains a lot of energy, as we're about to show you.
And for this, I'm going to need a special piece of equipment, Chris's hand. Now this is a cylinder of methane, and I'm going to release 1 day's worth of farts.
This experiment is highly dangerous. We're in a controlled lab using specially manufactured gas. Don't even think about trying this yourself.
Get your hand wet. Now scoop up those bubbles. That's right. Hold them well away from you.
I don't like the look of this. Ah! Zond, that was amazing.
So that's how much energy there is in a day's worth of farts.
Exactly. That's 1 day's worth of farts.
Well, you know what we have to do now?
A week's worth.
Precisely.
1 week's worth of farts. That's really good, isn't it? So we've done a day.
We've done a week.
Dare we do a month?
Yes, we do. Dare. Do it.
Here we go.
Bite it.
Wow!
That was amazing.
Wow!
So we've shown you just how incredible your intestines are and how much energy there is in your farts. Remember, when you let rip, it's an essential part of how your body gets rid of excess gas.
And now you know whose fault it is that you do them in the first place, those cheeky little gut bacteria. But if they weren't in our intestines, we'd end up with undigested food sitting in there forever. So there really is no reason to be ashamed of your